Okay, let's talk about some other special segments. A median extends from the vertex of a triangle to the, and if you look at the picture, it's the midpoint of the opposite side. Triangle has three sides, therefore it has three medians. You look at the picture, it starts up here at point L, that's the vertex, goes down to the midpoint O. I know O is a midpoint because of the tick marks. All three medians intersect. That point is called the centroid. So if you look at my picture, I've got medians PZ, CX, AY. They all meet at point P. Point P is called the centroid. Now, what's special about the centroid is that it splits the entire BZ into two pieces. You got piece BP and you got piece PZ. Well, PZ is 1/3 of the entire line. P to B is 2/3 of the entire line. So your line gets split up into three parts, where PB is going to be 2/3 and P to Z is going to be 1/3. So let's do an example of this. If I look here, AF is 9, so this entire median is 9. Well, if I split it into threes, I know that this little piece G to F has to be 3, because 1/3 of 9 is 3, and A to G has to be 6. Do you see how AG is twice the size as G to F, but added together they still equal 9? So AG is 6. G to E is 2.4. So this is the 1/3 piece, 2.4. So that means that the distance from G to C has to be double that, which would be 4.8. So CE is 3 times 2.4, which is 7.2. The segment we have is called an altitude. Altitude extends from the vertex of a triangle to the opposite side at A. And if you look at the picture, that's a 90-degree angle. So it has to be perpendicular. The triangle has three sides. Therefore, it has three altitudes. What's special about an altitude is an altitude can be inside, outside, or on a triangle. So the pictures down here kind of showed you, here's some altitudes. On an acute triangle, the altitudes are inside. But on a right triangle, the altitudes, you have one inside and the other two are on the triangle. That would be AE and EB. Those two are altitudes of a right triangle. And when you have an obtuse triangle, one of the altitudes is inside the triangle. The other two, AD and EB, are outside the triangle. So you got to figure out what type of triangle you have, and it's going to depend where the altitudes go. Okay, the point where all three altitudes intersect is called the orthocenter. So if you look at my pictures, The orthocenter could be inside the triangle, on the triangle, or outside the triangle, depending on what type of triangle you have. If a triangle is isosceles, so here in this case, isosceles, AB and BC are equal. What happens is this altitude, because it goes from the vertex A down at a 90-degree angle, so AD is your altitude. But what is it doing to side BC? It's actually bisecting side BC, creating BD and DC being equal to each other. So if you have a nice altitude of an isosceles triangle, that is also called a median. It's also called a perpendicular bisector. Bless you. And this thing is also an angle bisector. So if you have an isosceles or equilateral triangle, altitude could be a median, a perpendicular bisector, or an angle bisector, meaning that these two angles up here are going to be equal to each other. Find the orthocenter. We just said that the orthocenter goes with the altitudes, and the altitudes extend from a vertex straight down at a 90-degree angle. Well, without doing any steps, the easiest altitude to draw in right now would be the altitude that goes from K. So vertex K, it's going to go straight down. Well, if it goes straight down vertically, that has an undefined slope, and JL has a zero slope, so we know that makes a 90-degree angle. So there's your first altitude. The other altitudes are a little bit harder to find, so first thing we did was we need to pick a vertex. So let's pick vertex. In this example, let's pick vertex L. Step 2, let's find the slope of the opposite side of L. So what side's opposite of L? That's going to be JK. So I need to find the slope of JK. So to find slope, we can use slope formula, or we can count, start at J, rise over run up 4 over 2. So my slope is 4 over 2, which reduces to 2 over 1. Well, what do we have to do to that slope? Since we know that if it extends from point L to JK, it has to be perpendicular. So we have to find the opposite reciprocal slope. So my new slope is going to be -1 over 2. Have fun. Now we're going to start at the vertex we picked and count the new slope. So if I start at vertex L and I count the new slope down 1 over 2, I end up at 4, 1. So instead of going down 1 to the right 2, I want to go up 1 to the left 2, up 1 to the left 2, up 1 to the left 2. When I do that, I extend my line out. And we could draw the third one point in there if we wanted, but right now we have enough information to show that the orthocenter is located right here at -2, 4. So you could go through those 3 steps again and do J and KL. But that line would also intersect through that point.